So previously we talked about how important it is to validate user inputs. If a user ever gives you a value, you should validate that value to make sure that it's going to actually work with the rest of the code that you've written. The problem with that is that eventually you're going to create something that isn't really intended to be used by end users, but by other programmers. So you may eventually take some code and put it online or package it as part of a library and submit it for other programmers to use. And in that case, validation isn't going to help us that much because there is no user. There's no way to ask somebody to enter a new value since they're actually creating objects and using the code that you've written. So we need another way to indicate when problems arise due to invalid inputs to a constructor, for example, for one of my objects. The way that we do that is with exceptions. So if we refer back to our computer class, right, we see that I have this constructor, and the constructor takes in a few values, including the memory and the size and the processor. None of those values can be below 0. It's not possible for a computer to have a negative amount of memory. So if somebody tried to create a computer with a negative amount of memory, that would be a problem. That would be something that right now we're allowing them to do, but really isn't a realistic representation of what a computer is. So if we wanted to disallow that kind of behavior from occurring, we can actually use what's called an exception. So what we'll do is we will create a simple if statement that checks to see if memory is less than 0. And if it is, what we're going to do is we're going to throw an exception. So throw is a special keyword in Eclipse, in Java rather, that allows us to throw an exception to give some kind of an error. So what we're going to do is we're going to throw, then you see the word new. That's an indicator that I'm about to construct something. I'm about to create an object. So exceptions are objects like many other things in Java. And now we have a decision. There are many different types of exceptions that exist. We need to choose the exception type that is um, best represents the kind of problem that we have in this particular situation. So in this situation, we have a problem because somebody has given us an illegal argument. They've given us this memory argument that is not correct. So a good exception for this is called an illegal argument exception. This is an exception that Java provides to us. You can find a list of exceptions that Java provides in the Java documentation. So now that we have this exception in place, let's see what happens when we actually try to do something that's not allowed. I'm going to go down here to my main method and find this computer that I've created, and I'm just going to make it negative. We said that I don't want to allow negative memory values, so what's actually going to happen if I give it a negative memory value? Well, let's try it out and see. When I run this, what you'll see in the console is something that you've probably seen many times before. It gives us this red text and tells us that there was a problem with our code and tells us what lines caused the problem. This time, you'll notice that the problem that was given to us is an illegal argument exception. That's the exception that we created up here. That's the very exception that we created right up here. Right? So let's think from the perspective of somebody that's trying to create computer objects, and maybe we're not sure if what we're doing is correct or not. Maybe we feel like what we're doing is okay and we want it to work, but we also suspect that there might be some sort of a problem with what we're trying to do. Well, there's a way for us to prepare for those kinds of situations, to prepare for any exceptions that might be thrown, and to handle those exceptions in some way. So the way that we're going to do this is with a control structure called a try-catch block. So what I'm going to do is down here with this code that we saw doesn't work anymore, we threw an exception to prevent this from working, I'm going to put the word try up here, and I'm going to put these lines of code inside of this try block. So anything that I suspect might not work for whatever reason, I'm going to put inside of this try block. And now I need a second step called a catch statement. So the catch statement is only going to execute if an exception is thrown, if an error occurs. So I have to tell it what kinds of exceptions I'm looking for. In this case, I know I'm looking for an illegal argument exception. And I have to give this exception a name. Traditionally, the name is E. So now inside of my catch block, I can do what's called handling the exception, which typically means printing out a message to describe what happened, um, giving any other information that I have that might help in determining why this exception was caused. Cannot create computer. And also, traditionally, what we'll do is I'll take the exception, which I've called E, and I'll do something called print out the stack trace, which is actually what you see right here. This red text at the bottom of the screen is called a stack trace. So that's some useful information that can help us figure out what exactly went wrong. So now if I try this, right? Now if I try this, you'll see that what happens instead is it tells me it cannot create the computer, and then it prints out the stack trace that was generated. That means we went to the catch block, right? This would not have happened if we had not caught that exception. But what if everything works smoothly? What if everything behaves the way that we expect it to? Well, let me take the negative sign off and show you what happens. Now, when everything behaves the way that we expect, it just does what's in the try block. And if there are no exceptions, if no errors occur, if there's nothing that needs to be handled, I will just skip everything that's in this catch block and move on to whatever's next in my code. So I can use these try-catch statements to help us detect our exceptions, to help us detect when exceptions take place and do something, try a different method, display some information about what the problem is so that we can try to fix it, or some, just in general, try to handle the exceptions that are being thrown by my code. Now, you should be testing your exceptions as well. You should be testing any exceptions that are being thrown in your code with unit tests. So if I go over to my tester and I want to test the exceptions that I just added in, right? I'll say test invalid memory, right? What I can do is something like this. I'm going to use a try-catch block to test this exception. I'm going to cause something that will throw the exception. And if the exception is thrown, then I will succeed. If the exception is not thrown, that means I'm not detecting errors properly, then I will cause it to fail. So let's try to create a computer. I'll just grab this computer up here. What I want to do, since I'm testing the exception, I actually want to give it a bad value. So I'm going to give it a bad value. And down here I'll say catch, just like we did before. And if I catch, that actually means that I want to pass. That's not the right word. I will say, well, I could just say assert true. True. Right? I want this test to pass. If I don't throw an exception properly, then I want this thing to fail. And so I can give a message invalid value. Right? So I want this to fail. Okay? So now, whoops, now if I fix my syntax here and try this test out, I know that this will work. I know that this is going to throw an exception. So when I run this test, I actually expect it to pass. So let me come down here to run as JUnit test. Okay, and you see that it did catch the exception. So everything worked as expected. However, if I go back and I take the exception out, so it doesn't throw the exception, it doesn't behave the way that I expect, it's not detecting that invalid value, and then I try to run the test, you see that instead, since it never made it to the catch block, it never actually made it to this passing statement, I hit the fail statement instead, and it says an exception was not thrown for an invalid value. This is how we unit test our exceptions.